Hi, everyone, and welcome to part two of our section 6.3 logarithm section. And before we get started, and this is not going to be a very long session, hopefully, it'll make sense. But before we go too far, I just want to remind you of where we are now. So at this point, you should be able to get back out of there. Um, you should be able to do two things. One is we have this thing called exponential form, and we have this thing called logarithmic form. And you need to be able to change from one to the other. The better you are at changing it, the more practice you get, the easier it gets, the easier it sounds. All right, but let me give you an example. So if I have something like, what I'm going to do is I'm going to write things in exponential form, and then we'll convert them into log form. So if I have, for instance, let me do a simple one, is 2 to the third equals 8. In logarithmic form, it's going to be log base 2 of 8 equals 3. And again, if you remember, the exponent in the log are the same thing. So, and the base is the base. So let me show you a couple other ones. We could have 3 squared equals 9. And the way I would convert that to log form would be to say log base what, anyone? I think I heard you say 3 of the number 9 is going to be equal to 2. Okay, again, just get used to that ability to move from one to the other. Now, there's a couple interesting exponential equations that we're going to see, and I just want to make sure demystify the notation. But anytime we have something like this, like 10 to the third equals, in this case, it's going to be 1,000. And if I convert that to log form, I would like to write. I think a lot of you would be tempted to write log base 10 of 1,000 is equal to 3. But in this case, because the log base 10 is such a popular logarithm and has been apparently for centuries, we often admit, as we do in so many cases, anything that's really repetitive in algebra, we just tend to not do. So if you see log, all right, of 1,000 equals 3, that means the same thing. The log base 10, the log base 10 of the log base 10 is usually just written as log. So if you do not see the number underneath it, the base, then that means it's log base 10. So anyway, that's going to be one of the abbreviations. So again, just to reiterate, log all by itself means the same thing as log base 10. And there's one other very, 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 very popular base, and that's E. So I'm going to give you an example. So if I have E, which is approximately 2.72, E squared equals, and this is approximate actually, I probably shouldn't put an equal sign, I'll say 7.39. I just did that in my calculator, right? So it's approximately equal to that. So what I'm going to do is, if I rewrite that in log form, I'm going to say that the log base E of 7.39, guys, don't leave me yet, equals 2, approximately 2, right? Well, because log base E is so popular, they have also decided that they will abbreviate that. So instead of log base E, they write LN, which means log naturel. It's some French, or the French equivalent of what I just tried to utter. So that's going to be rewritten as log LN, natural log of 7.39 equals 2. So again, log base E and ln, log base E, it means the same thing as ln. So these are, so when you see that ln, don't freak out. It just means log base e, and it's shorthand for that. So we're just gonna, I just wanted to show you that just so that when you see it in the upcoming section here, it'll make more sense to you. Okay, next page. We're almost done here. Okay, so example 3. What we're going to be doing here is we're going to be, they say, evaluate the logarithm. In other words, what I'm going to ask you to do is, this is the way I like to do it, is I just want you to rewrite this in exponential form. So the log base 4 of 64 is asking the question, 4 to the x, 4 to what exponent is equal to 64? So we're going in the opposite direction. So 4 times 4 times 4, believe it or not, is 64. So what will x be equal to in this case? So I could rewrite it this way. You may not want to do that, but I could say that 64 is the same thing as 4 to the third. And once I have the same base, these exponents have to be equal. So evaluating the logarithm, in this case, x, the logarithm, is equal to 3. All right, well, let's go to this next one. This next one is a little tricky, but let's go ahead and see what the question it's asking. It's saying log base 5 of 0.2. It's asking the question, it says 5 to the x is equal to 0.2. Now, that looks like a problem until I convert that decimal into a fraction. So let's see if you guys can remember. What is 0.2 as a fraction? Well, that's the same thing as 2/10. So this is 5 to the x equals 2/10. Well, let me simplify that. 5 to the x equals 1/5. That looks like something that may be familiar. How do I move the 5 from the numerator here to the denominator here? Well, if you remember, a negative exponent flips the number, right? Moves it to the other side of the fraction bar. So in this case, it would be 5 to the negative 1 is equal to that 1/5. So x therefore would equal negative 1. What is that exponent? That exponent is negative 1. Okay, you're going to use a negative exponent on this next one also. So be ready. 1/5. Notice I put the parentheses around it, to the x power equals 125. Ooh, let's, what are we going to do here? Well, we know that 125 is 5 to the third, right? But right now I have a 1/5. So how might I change that 1/5 to a 5? What do I do to flip the number from one side of the fraction bar to the other? Well, if you remember, that's going to be the same as 5 to the negative x. The negative is what flips it. If I'm going to unflip it, I'm going to make a negative. Now that one you may have to take a moment and think about, but x to the 5 to the negative x is going to be the same thing as 1 over 5 to the positive x. If that makes sense to you, we have the same bases again, and therefore I can say that negative x, which is my log that I'm evaluating, is equal to 3. Therefore x will equal, divide both sides by negative 1, negative 3. One of the things I feel like I want to go back and look at again was this one B. What I didn't do there is what I should have done there is to be consistent would be to rewrite both sides to the same base. So I'm gonna actually I'm gonna, just in terms of being consistent, so that we're doing the same thing each time, I'm going to redo this one so that we have the same base on both sides, and then we can make the exponents equal. So I'm just going to keep it as 5x. And how do I write 1 over 5 to have a, so that the 5 is in the numerator? Well, again, to flip it, I need to give it a negative exponent. So 5 to the negative 1 is the same thing as 1 over 5. Now I can say that the x is equal to the negative 1. So I hope you're okay with my going back and redoing that. That way, again, we're keeping consistent in trying to keep the bases on both sides the same. So let's think of that concept. The idea is we want to get the same base on both sides so we can set the exponents equal. So this next one is going to say 36 to the something power is equal to 6. So how can I get both sides to have the same base? Now, some of you may recognize that 36 as being related to the 6. So let's think about that. What is 36 as a base 6 number? Well, that's going to be 6 squared, but we still have our x equals 6. Well, what is the rule for a power to a power? 6 to the 2x equals 6 to the, and if you will, the 1. Now the bases are the same. So whatever you need to do to make the bases the same so that we can make the exponents equal allows us to evaluate the log. Divide by 2, and therefore x is equal to 1/2. And that makes sense. If you take the original equation, you remember 36 to the 1/2 is the same thing as the square root of 36, right? So that works. Anyway, what I'd like you to do right now is attempt the 2 problems on, let me see, on the next page. See what we did to, get the bases the same, right? And go ahead. Yes, I'd like you to try on your own. If you go to page 7, I guess it is right here, or it might be page 6 for you guys. And if you can see this log base 2 of 32, and then the log base 27 of 3. Those are the 2 questions that I'd like you to do on your own. So if you can pause this video for a moment and take a stab at this, that would be great. So take a look at the one we did before, see what we did to then at these questions here, number 9 and number 10. Pause now, and when you come back, you'll see I'll have the work done for you, and you can check and see how you did. Okay, so go ahead and pause. Okay, welcome back. And here is the work that you hopefully figured out. If you didn't, take a look closely, see if it makes sense. So again, I start with my original, number 9, I start with my original, convert it to exponential form, 2 to the x equals 32. And now the question is, can I make the bases the same? Well, the base on the left is 2. I certainly can't do anything to make it smaller, but if you recall, 32 is the same as 2 to the 5th. So 2 to the x equals 2 to the 5th. The 2 exponents are the same, so x equals 5. Number 10 seems a little trickier, but think again. You see the 27 on the left and the 3 on the right. Largely what we're going to be trying to do is create the base of the smaller number. So the smaller number in this case is the 3. So question, 3 to what power might be 27? If there's no answer to that question, you can't do this problem without a calculator. So it has to, in this situation, it's going to have to work. So it's going to be 3 to the 3rd, though. 3 times 3 times 3 is 27. And so now I've got, if you can see, I've got the 3 to the 3rd to the x power. And so again, I just multiply the 3 and the x to get 3 to the 3x. Now I've got the bases the same on both sides. I can set the exponents equal to each other. So the exponents in this case are going to be, before I do that, so the exponents are going to be 3x and 1, and I divide both sides by 3, and I get x equals 1/3. So, and it does make sense if you think about it, because it's so that this is basically saying that 27, if I take the original equation down here, right, I go 27 to the 1/3 equals 3. And if you remember, the 1/3 means third root. Okay, well, let's go to the example 4. So example 4 is right above us. And so let's go ahead and see what they're doing here. On this one here, what we're going to be doing is using the calculator to evaluate those the log base 10 of 8 and the natural log of 3. So let me get a calculator. Okay, so here's my calculator. You will need to find your calculator. So if you need to, go ahead and pause until you can find that. So let's go ahead and look at the first one, log of 8. Now the log buttons are right down here. Do you see it? And there it is, log. And notice it's the blue on top. That's the exponential, the 10 to the x key that we used to use in the old days. And the other key we're going to be using is this one here, ln, which again is log base e, or just the natural log, as they call it. Okay, so let's go ahead and do log 8. This is pretty simple. So what we're going to do is just push the log button. Whoop, okay. Log and the number 8. And then enter. And so the answer is 0.903. That basically is telling us that 10 to the 0.9 is 8. But you never knew that. So let me see if I can move this off to the side. So log base e, log of 8 is equal to, I said what, 0.903. So it's interesting. 10 there we can make 10 to some exponent any possible number, but in this case it's going to be this 0.9031. I'm not sure what big ideas is going to look like, but typically we look at 4 digits, decimals on our logarithms. Okay, so the next one says ln 0.3. So natural log of 0.3 means that we're going to go to ln right here. Push that, and 0.3. You don't have to close the parentheses, and the answer here is negative 1 point. Go ahead and natural log of 0.3 equals negative 1.2040 if you round it to the thousandths place. So anyway, that's how we're going to do those numbers with the calculator. So right now, what I'm going to ask you to do is to, let me see if we can turn this off. Whoop. Okay, sorry about that. Let me get rid of this thing. Just push it off to the side. Okay, good. So what I'd like you to do right now is to do number 11 and number 12 on the bottom of this page. Again, you're going to use your calculator to do that. So if you guys could just take a moment and evaluate those two and round it to they said 3 decimal places, but go ahead and round it to 3 decimal places. I guess I rounded it to 4 above, but either way works fine. Okay, so go ahead and pause this video and see if you can get the calculator to spit out those 2 answers for you. Okay, I hope that worked out okay for you guys. But anyway, log of 12 is 1.079, which interestingly, I know you guys don't care, but that means that 10 to the 1.079 is equal to the number 12. So a whole nother way of writing a dozen. So if you ever want, you can now order 10 to the 1.079 donuts. The natural log of 0.075 is negative 0.288. Hopefully, I did that right. But anyway, so your homework tonight will be mostly doing questions like numbers 9 and 12, where you're trying to evaluate the value of the log, and you're going to do that by trying to get writing it in exponential form and trying to rewrite it with a common base. And typically, the base that we're looking at is the smaller of the two numbers on either side of the equal sign. So you have questions like 9 and 10, and then the easy part of your homework will just be to evaluate those logarithms. And that's about it. You guys have a good one, and I'll see you at the next meet session where we will tackle the homework assignment if you haven't already tackled it yourself. So you guys take care, and I'll see you at our next meet session. Bye now. Try your metal at the